In this video, you will learn the connection between a table, an equation, and a graph. Let's say it starts snowing at midnight in town A and town B. The snow falls at a rate of 1.5 inches per hour. In town A, there is no snow on the ground at midnight. So you can see on the graph, at 0 hours, I put a point at 0, 0. How deep is the snow at each hour between midnight and 6 a.m.? We can make a table to keep track of the depth of the snow after each hour. So the time is 0 hours, 1, 2, 3, 4, 5, and 6 hours, because after 6 hours, it will be 6 a.m. The snow falls at a rate of 1.5 inches per hour. So every hour, we should have 1.5 inches more of snow. At midnight, or 0 hours, we have 0 inches of snow. But by 1 a.m., we have 1.5 inches of snow. At 2 a.m., there are 3 inches of snow. At 3 a.m., there are 4.5 inches of snow. At 4 a.m., there are 6 inches of snow. At 5 a.m., there are 7.5 inches of snow. And finally, by 6 a.m., there are 9 inches of snow on the ground. So on the graph, we can put all of those points. You can see that they go in a nice straight line. That's because the rate stayed the same the whole time, 1.5 inches every hour. And all of that can be represented by the equation y equals 1.5x, because whatever the number of hours is, which is x, if you multiply it by 1.5, y is going to be equal to the number of inches of snow on the ground. In town B, there are already 4 inches of snow on the ground from a previous snowfall. Let's make a table and a graph showing how much snow will be on the ground after each hour in town B. You can see there's a blue point on the graph at 0, 4. That's because at 0 hours, which is midnight, there are 4 inches of snow on the ground. Now here's the table. 0 hours, 4 inches of snow. At 1 a.m., there should be 5.5 inches. At 2 a.m., there should be 7 inches of snow. At 3 a.m., 8.5 inches of snow. At 4 a.m., 10 inches of snow. At 5 a.m., 11.5 inches of snow. And by 6 a.m., there should be 13 inches of snow. When we plot all of these points on the graph, you can see that they're a little bit higher up than the graph for town A. That's because, remember, town B started with 4 inches of snow on the ground. So no matter what hour it is, while this snow is falling, town B is going to have 4 more inches of snow on the ground than town A. These points also go in a nice straight line because the rate is 1.5 inches per hour. If the rate were to change throughout the night, it would not be able to be a nice straight line. All of this data can be represented by the equation y equals 1.5x plus 4. It's very similar to the first equation, y equals 1.5x, because the snow falls at the same rate. That 1.5 is the rate that the snow is falling. The plus 4 on the blue line represents the first hour, the 0 hour. At midnight, there were 4 inches of snow on the ground already. So no matter what hour it is, town B, the blue town, will always have 4 more inches of snow than town A, the red town. A linear equation is an equation whose graph is a line. The word linear has the word line right in it. That's a good way to remember what it is. This line cannot stop or curve or turn like a corner. It has to continue going straight in the same direction. The points on a line are solutions of an equation. For example, 0, 1, 5, negative 7. Those solutions have x, y, and they can be substituted in for the x and the y in the equation and make the equation true. Let's try a few examples. Y equals negative 2x plus 1. The first step is to make a table of values. These values are going to be the solutions or the points that we could substitute into the equation for x and y to make the equation true. We're going to try substituting in the values negative 1, 0, and 2 for x, and each time we'll see what we get for y. When we substitute in negative 1, now we can use the order of operations to figure out what y would be. Negative 2 times negative 1 is positive 2. Then add 1, and we get 3. Y equals 3. That gives us a point or a solution -1, 3. The second step is to go ahead and plot the ordered pairs right on the graph. So I'll go ahead and do that as we go. The first solution we just got was -1, 3. Next, let's try substituting in 0 for x. -2 times 0 is 0, then add 1, and we get 1. So the solution, or ordered pair, is 0, 1. So there's now a point on 0, 1. Finally, let's substitute in 2 for x. Y equals -2 times 2, which is -4, plus 1, which is -3. So the final solution, or ordered pair, that we have for this equation is 2, -3. So we went ahead and put a point on the graph. That does not mean that those are the only three numbers or values that we can put in for x and y. You actually can put in any value for x and try to figure out what you get for y. The entire straight line that we draw through all these points actually represents every single possible solution, even if it's not on one of the points that we drew. The third step is to draw a line through the points. When you do this on paper, it's very important that you use a straight edge. Here's the line. Notice it goes through all 3 points that we drew. Also notice the arrows at the ends of the line. Whenever you graph a line, you should be making sure that it's straight and that it goes through all the points that you graphed. Also that it has arrows on both ends, because it means that the line goes forever in both directions. Now you should know the connection between a table, an equation, and a graph. Please watch the next video.